Some basic information about software-defined WAN, or SD-WAN, and what a typical SD-WAN solution looks like. The main topics we'll cover are the main functional components, the process of connecting a new branch to an SD-WAN network, multi-tenancy in an SD-WAN, and some of the business drivers for SD-WAN. A typical SD-WAN architecture will include several components. First of all, there will be some type of network to connect locations. Common WAN connection types include MPLS-based services and public internet connections. Branches use these public and private network services to communicate with each other. Many deployments require that remote sites connect to a hub location that serves as a centralized connecting point. It's common to find hub devices at a corporate headquarters office, at a data center, or wherever a pool of resources is located that will be accessed by branch devices. The head-end components are responsible for provisioning the branch and hub devices, for authorizing them on the network, and providing configuration parameters. Although it's common to host head-end components in the same location as the hub components, remember that they are separate components and have different roles in the network. The head-end components are the foundation of the SD-WAN environment. The head-end components consist of the control component, which manages the reachability information within the SD-WAN environment. The management component, which authorizes devices, provides management of the environment, and configuration of the edge devices. And although not always present, a mature SD-WAN environment will include a logging or accounting component, which keeps track of network performance and functions within the environment. The control component is responsible for establishing the control plane. In the example, if a new network is connected to branch 1, the branch 1 device informs the controller of the new network segment, and the controller provides information about the network segment to other devices in the WAN that need to know about that new network. The management component is responsible for how the environment works. For example, when devices in the network require a configuration change, the management component is used to apply those changes to individual devices, groups of devices, or all devices. The process of connecting a new device to the SD-WAN is called onboarding. When a new device is connected to the SD-WAN, which is the Office 3 branch in our example, it first must receive an IP address. In the example, it receives the IP address through DHCP from the WAN service provider. By default, it tries to connect to the global call home server or pre-staging server. The pre-staging server is pre-configured with information about that branch device, such as to what organization it belongs and what head-end it should use to authenticate and join the network. Once the device receives its pre-staging information, it contacts the head-end components specific to that device. After authentication to the head-end components, the manager provides the configuration needed to participate in the network. Once the configuration becomes active, the branch device gains access to the control network, where it receives the routing and forwarding information it needs to reach other corporate sites. Next, we'll look at multi-tenancy. In a single-tenant environment, dedicated resources are provided to each customer, each department, or each tenant. In a multi-tenant environment, network resources are shared among multiple customers, departments, or tenants, but their information is kept separate and isolated by the networking devices. Role-based access control is used to ensure that resources available to one group are not available to other groups. From an organizational perspective, the use of multi-tenant functions can allow an organization to separate departments, branches, or office roles into isolated networking environments without having to purchase and manage a separate set of networking devices for each group. From a service provider perspective, Multi-tenant technologies allow the use of shared networking infrastructure to service multiple customers. Next, we will look at business drivers for the global adoption of SD-WAN waste architectures. The first business driver is simplified provisioning and branch onboarding. With minimal manual efforts or with zero-touch provisioning, a branch can be staged and start operating as an SD-WAN branch very quickly. The onboarding procedure is automated to reduce the time taken to onboard a new location and make it less dependent on the remote site engineer's competency. With current onboarding methods, bringing a new site online may just involve plugging a laptop into the branch device, opening a web browser, and clicking on a link in an email. What used to take on-site engineers and many weeks to plan can be done in just a few minutes by local employees. The second business driver is hybrid WAN. Instead of relying only on private WAN connections, a combination of WAN technologies can be used at the same time with intelligent path selection based on WAN link performance. SD-WAN architecture fundamentally creates an overlay IP fabric which is transport agnostic. Any kind of underlay network could be used to build this cloud IP network: private VPN, public internet, LTE, and so forth. Customers can utilize their WAN resources in the most optimal way by defining traffic steering policies. These policies can be based on delay, jitter, packet loss, and even application type, so that applications that demand higher network performance can be forwarded on the most optimal link at all times. The third business driver is network visibility. Next-gen WAN architectures provide in-depth analytics and visibility of network services with complex correlation on various performance parameters. This helps businesses identify loopholes in their present network architectures and take corrective actions. It helps in better planning and resource augmentation to support growing business needs and increase the efficiency of the WAN environment. The fourth business driver is administration improvements. SD-WAN architectures are focused on simplifying network administration, which includes planning, provisioning, management, and operations. All of these tasks are performed from a single pane of glass. The management plane, which is responsible to manage end-to-end lifecycle of software-defined WAN, improves the ability of network administrators to configure, deploy, and manage devices. It helps ensure that consistent traffic and security policies are implemented across the environment and reduces human error when configuring systems. The fifth business driver is automation. Modern networks are dynamic, with a lot of conditional requirements. Automation helps achieve agility by making dynamic changes to the design and adapting to changes in the network without manual intervention. An example of this would be monitoring WAN link usage and to automatically reduce traffic flow over an interface once it has reached a monthly threshold. This can be done without user intervention, as can many other tasks in the network. And lastly, performance improvements and a predictable end-user experience has always been a major concern for enterprises. SD-WAN addresses these concerns by making networking services intelligent, and with the help of automation, network environments can adapt to different situations which could potentially impact end-user experience. Instead of receiving technical support calls when network performance issues arise, modern SD-WAN environments can monitor the network and application performance, and through automation, changes can be made that can fix a problem before it impacts the end users. This results in satisfied end users and better results for the enterprise. This is the end of Session 2 of the Versa Essentials series. In this session, we looked at a typical SD-WAN environment, the main functional components of an SD-WAN, device onboarding, multi-tenancy concepts, and business drivers for SD-WAN. Thank you for your participation in this session, and we hope you found the session informative.